Perfect. Okay, so thank you very much for being here and in this presentation. The title of this presentation is Reasoning about Conscious Experience with Axiomatic and Graphical Mathematics. So let's start with a few motivations. When we study conscious experience, we always tend to have certain underlying assumptions. These assumptions can be explicit or implicit. For example, the materialistic assumption is that the mind and experience itself emerge in the best of the case, but also, or it's reduced to computations in the brain. But this is not the only assumption. We also have other type of assumptions like the idealism, where actually the physical realm emerge from the experiential one. But the brain basically is just the brain. It's a biological living system. It's not a physical system per se. We cannot perhaps reduce it simply to a physical one. And therefore, we should probably have another alternative assumption, which is bracketing the ontology and pragmatically study how the mind and the physics co-emerge or mutually constrain each other in a non-dualistic way. So in this line of thought, which is the continental phenomenology, the basic question is, what is consciousness itself doing instead of the brain or any other biological physical system regarding experience? So if you would like to know a little bit more about these connections of assumptions and models, I would recommend you to check this paper, Explanatory Profiles of Models of Consciousness, with Joanna and Robert as co-authors. And in the rest of this presentation, we are going to speak about this other paper that is probably going online soon during this week, in collaboration with Quanglong Wang and Bob Koke. Quanglong, or Harney, is going to present also some of his work in the next presentation. So very quickly here, we use category theory as the umbrella framework for the rest of this presentation and paper. And the main idea here, probably you are quite familiar with this, it's the basic idea that when you define a category M, you can map this category in another category N, and this mapping via functor relationship, it's called also an interpretation of M into M. More specifically, we are going to use process theory, which are very specific categories, symmetrical monoidal categories. And the nice things about this, we already saw one example with Vincent's presentation, is that we can translate certain mathematical expressions in graphical terms, such that we can show easily what is sequential composition and parallel composition. In a process theory, we always have or most of the time we have a set of generators that characterize the phenomena that we want to model, and this becomes the syntax of the theory. In our case, we are going to assume that some of these processes are experiential processes without any lack of generality. More specifically, we are going to use a fragment of CW calculus, which is a type of process theory. And in this case, we have a couple of, we have a few generators here. And these generators, oh, sorry, I just realized that I didn't, sorry. So this set of generators define the main syntax of the calculus, and they also have a set of rewriting rules that are diagrammatical equations, graphical equations that capture the composition of these generators. These rewriting rules are important because they specify the generators, and also, like I said before, they capture the full theory. So just to make our assumptions more explicit, here we are going to consider that diagrams already convey certain experiential phenomenology. So in this case, experience is fundamental, and therefore diagrams are fundamental. You can also understand this as mapping physics into experience and vice versa. And the second main assumption is that quality subsumes quantity. A quantity is always an fuzzy quality. And something that, a quote that I think it's relevant here that explain a little bit what we have in mind is this one here. If mathematics is the science of analogy, the study of patterns, then category theory is the study of patterns of mathematical thought. So this is what we have more or less in mind with the next slide. So in concrete, what we did here is to translate certain phenomenological features of conscious experience into more precise definitions and then into mathematical generators. So let's start with unity. Experience possesses unity as long as it cannot be written as disconnected diagrams. And we had these examples here as generators that will represent unity. Then we also define quality and quantity in one generator, such as experience possesses quality as long as it contains trivial topological relationships that are not trivial for formal statements. So basically, we model it with this spider here, and R inside would be the quantity, while the shape will be the quality. And subjectivity process would be in relation to the previous one, such that they both form a B-algebra structure. And we represented like this with this generator. And the final one, it's the distinction process, interesting feature of consciousness, because experience generates distinctions that breaks invariability of primitive unity and discriminate between subject-object, inside-outside, identical, different, etc. And we represent that with this spider here, and we postulate that it's the input of this process is external, and wherever is the output would be internal experience, etc. And all these diagrams here, they combine each other as a fusion rule. So what we can do with this, well, we can define conscious experience in a very simple way. We can just say that this is the composition of qualitative quantitative process with subjective one, such that rewriting rules become equivalent relationships between minimal experiences. We can also say that conscious perception, it's the composition of these three generators. Here, for example, we can perceive this is an example of perception of the quantity R, for example, such that it crosses the distinction process. And we get from these different rewriting rules or rules of composition that allow us to prove the privacy of subjective experience. So the privacy of subjective experience is the impossibility to perceive or read the subjective experience that is external to us. So we model this, or we prove the existence of that with this very simple graphical proof here, because we know from the rewriting rules that this external subjective experience can never cross this distinction process, so will never become internal. And this is the way how we prove that this subjective experience, it's private. This subjective experience here, it's private to the internal observer that will be here. This could be probably the main result of our paper, but there are also other interesting consequences here. We can compare experiences using this very simple model. For example, let's take an experience of a workshop in Corsica, and let's assume that we can model it with this circuit here. So then different transformation or modification of this circuit via rewriting rules will become different instances of the same experience, such that at the end, the final decomposition could help us to compare between other theories, between other experiences that seems different, but actually they convey similar aspects. And the same for other experiences that probably are completely different, like living in Paris in a small studio. So the main idea here is that the phenomenal unity is given by the full circuit and the connectedness of this circuit, and the access unity, that people call sometimes access consciousness, is given by the modifications of this phenomenal field. The main idea is that rewriting rules become how experience modify each other to account for the compositions of experiences and distinctions among experience. So a few predictions, or prediction in between, in brackets, kind of, it's that, well, we predict certain diagrammatics and experiential equivalents that we can compare across different experiences and their instance of experiences. We can characterize a minimal set of irreductive experiences. We can also access to subjective experience only if we add new distinction. We don't have time to speak about that, but you can check in the paper. And finally, something that is counterintuitive here is that the mechanism of separation or distinction may be more relevant than the integration ones. And the conclusion here is that we can actually, with this very simple framework, translate phenomenology to mathematics directly without any ontological assumption, but actually it gives us a new advantage because just with the tools that we are using here, we can have a connection with physics almost for free. This is a formal tool to study experience. It's philosophically transparent, ontologically neutral. We can get certain, in brackets, predictions. It's pragmatic and rigorous. So what is the future work, the future steps? We expect to have a sound and complete calculus for this, this semantic. And we need for that, of course, collaboration with phenomenologists, philosophers, etc. It will take time, a couple of years for sure, but I think that it's possible to do. We also expect to recover certain physical aspects from experiential categories, and the most evident one is time and causality. And finally, we think that this simple, general, and rigorous framework can help us to combine different strategies and assumptions, because basically we don't believe that one of these assumptions is the real way to approach consciousness, or the assumption to approach consciousness, to see what happens or how far we go with each one of these different assumptions. And this is what we are trying to do. Here you saw an example of phenomenology, then you will see an example of alaya consciousness, and eventually, if you are interested in the close future, you will see other examples using multi-layer framework and for models, other type of models of consciousness, etc. So if you would like to collaborate in these things, etc., you can contact us and keep in touch. Thank you very much.